Okay, so good morning. Yesterday we were doing Dirac Delta Function, and probably today will be the last turn for this particular topic. Okay. Overall, understand what I want to do from this Dirac Delta Function is I just want to introduce you to all these concepts. Okay. So there are many instances where you'll find that this will be there. Overall, I will come to all those instances as and when I'll teach you the physics part. But overall, try to understand we have to make a strong grasp on this particular topic because it will be time and again used in the different other branches of physics as we go along. Okay. So overall, till now we have understood that Dirac delta function it represents a behavior where you have an infinite contribution at a point, and otherwise it does not have any sort of contribution. Okay. Secondly, they don't come in the proper definition of function. They are called as generalized function. Probably I'll take a class on it tomorrow, or distributions. Okay. Till now you have to understand this point that they are not so well behaved as if your conventional functions are. Okay. So what does it represent? It represents that Dirac of x is equals to minus and is equals to infinite if x is equal to 0 and x not equal to 0, then it's 0. And overall integral from minus infinite to plus infinite dx should be equals to 1. Okay, so that should be equals to 1. So these two properties constitute what you call as your Dirac delta function. Further, we also saw that this Dirac delta function, if because there is a problem with Dirac delta function that such function does not exist in true sense in in the theory of the well-behaved functions. Like so, what do? We actually represent it as limit of sequence of some functions. So we defined it as a limit of sequence of some functions, and we saw quite many functions, like around 4 to 5 functions, whose limiting behavior corresponds to the Dirac delta function. Okay, and further I did some properties with you. One of the properties was, let's say we were discussing some properties. And before going to okay, let us first discuss properties and then we'll come along. So we were discussing some properties. And the first property that we could we can see from the behavior of the different other sequence of function that the Dirac delta function is a symmetric function. So this is a symmetric function. Okay, or you can say that it is symmetric about whatever argument is there. For example, if x minus a is the argument, then it is symmetric about. Okay, and this was very much understood from the distribution from the sequence of functions. For example, whatever sequence of function we were taking, we could see that eventually as n tends to infinity also, it will behave as if it is a Dirac delta function. But overall, all these sequence of function, even as they grow narrower and narrower and narrower and narrower, they're actually symmetric about x equal to 0, because we were writing the definition about x equal to 0. If we slightly shifted our point at x equals to a, then this will be the symmetric conditions. Okay. Now further we can go along, and we went along and said that there's a filtering property. So there was a filtering property, or you can say selectivity, filtering property or selectivity. So what does a Dirac delta function do? Dirac delta function says that if minus infinity to infinity remains my case, and Dirac of x minus x naught, fx dx I'm evaluating, I'll get simply f of x naught. So basically, what does it do? From all the values from x belonging to minus infinity to plus infinity, it gives you the value of function at a point where your Dirac delta function is situated. So right now your Dirac delta function is actually having a peak at x equal to x naught. So it will give you the value function at that particular point. So basically, from all real values, from all real possible values, it is giving you the value of a function at a point. So this is a sort of a selectivity property. And I draw an analogous case. I actually went through the discrete analog of this particular function, which happens to be the Kronecker delta. And from Kronecker delta, I made an analog. I wrote an analogous result, and this is that result. Further, if you just see, let's say if I integrate from f a to b, f of x, Dirac of x minus x naught, then what shall be the answer? Anybody has any answer to it? What shall be the answer to it? So for example, if between a and b, somewhere your x naught lies, between mean exactly not between, like not midway, but anywhere between, if x naught lies then it makes sense. It will give you fx naught answer, because in the variable of in the limits of between the limits of integration, if your x naught lies, then answer would come as x naught. Otherwise, it would be 0. Because see, if you're not having this point in x between a and b, so for example, here is the point x naught. So you're integrating between a and b, and point x naught lies here. So there would be a peak at x equal to x naught. Otherwise, here the function is 0. So basically, you're integrating a to b f of x into 0 dx. So it will come out as 0. So understand my point, that if I integrate from a to b f of x Dirac of x minus x naught dx, then you are supposed to ask me, where does my x naught lie? If my x naught lies between a and b, then it's fine. Then it will be f x naught. Otherwise, it will be 0. Is that clear to you? Is that clear to you? कोई बोल भी नहीं रहा, क्या हो गया, मर गए सब?
हाँ भैया.
Okay, so now you see, agar iske baad what we did, another property was, I think Dirac of g of x was given as summation, I think x minus xi Dirac divided by modulus of g dash xi. This was the case only if xi is a simple 0. And I told you that such quantity like Dirac of x square is a meaningless affair, because here you have roots which are repeated. So you have to have you can write a Dirac of some function, like argument of Dirac can be a function. Then this result would be this, provided xi is a simple 0 to gx. Only in that case you can expand in this manner. Okay, and also I wrote a few results on I think Dirac cube r. I also explained it. It is equals to, I think, 4 pi. It was r cap upon r square, if you remember. So this was three-dimensional Dirac delta representation. And I told you that r cap upon r square is a positively oriented, positively diverging field. So the divergence ought to be positive, but it happened that the divergence was coming out as 0 with the conventional formula that we have for the radial part of the divergence. So for radial part of the divergence, we have this formula. So if I'm evaluating del dot v vector and I'm writing the radial part, then this is it. But overall, understand my point, this will come as 0. But this comes only 0 if r is not equal to 0. It turned out that all the contribution is coming from 0 only. So basically, this kind of expression must involve somewhere Dirac delta function, because all the contribution is coming from a point point that is r equal to 0. So therefore, we use some theorem from vector calculus, which suggested that integral v dot dA in any sphere enclosing this field would come out as 4 over 4 pi. And this should be equals to del dot v vector d tau. And overall, we made an understanding that del dot r cap upon r square should be equals to 4 pi Dirac cube. Okay. Overall, if someone asks you to write this particular thing in different other expression, and also I made a point that analogous to your integral, analogous to your one-dimensional integral, where minus infinite to infinite Dirac of x dx is equal to 1, you have an analogous result here, that is all space, that is entire space I'm covering, Dirac cube d tau should be equals to 1. Now, another problem arises because of the expression d tau. As you will go in the orthogonal curvilinear coordinates, or you can see that as we'll move to different other coordinate system, this d tau changes. So for example, if you're dealing with Cartesian coordinate, then dy is this. If you're dealing with, I think, polar coordinates, then this r, dr, sorry, polar coordinates like for cylindrical. So if you have a cylindrical coordinate system, then this is it. And if you're dealing with a spherical polar coordinate system, then it will be r square sine theta, d phi, and dr. This is how it is. Is that clear to you? So all these things may appear. All these things may appear. Now, if I have to write del cube r d tau integral should be equals to 1. What does it imply? It implies, let's say I'm dealing with the three-dimensional coordinate system. Then del cube r will be here. Here it will be equals to what? Here it will be equals to r square sine theta, d phi, and then dr. Okay, are you getting my point? So now there are terms which are related to this also, like sine theta, d phi. Now all these things, sine theta, d phi, all these things are extra, like they are extra. Are you getting my point? So they are basically now extra. In order to have a in order to scale them, so what I do, I would simply divide like what I want to say is, for example, now I want to write an expression of three-dimensional Dirac delta function. If I want to write an expression of three-dimensional Dirac delta function in spherical polar coordinates, in spherical polar coordinates, what I need to do, I need to divide it by r square sine theta. I have to divide it by r square sine theta. Otherwise, I'll get a wrong answer. If I don't do so, I'll get a wrong answer. So for example, I'll take an example and I'll make you understand what I want to say. So for example, if you have a charge at let's say, इसको ऐसे समझते हैं. If you have a charge at origin, how would you write this particular quantity? You will say that my charge rho, volume charge density. How would you write the volume charge density of this point charge? You'll write Q times Dirac X, Dirac Y, and Dirac Z. It suggests that your Q is situated at X equal to 0, Y equal to 0, and Z equal to 0, isn't it? This means that your charge Q is situated at X equal to 0, Y equal to 0, and Z equal to 0. If I have to write my charge distribution, in terms of your cylindrical polar coordinates, if I have to write the volume charge distribution, we'll come to all these things later on also, but just for instance, I'm giving you this example. If I have to write my volume charge distribution of point charge Q in cylindrical polar coordinates, in cylindrical polar coordinates, what would I do? Now, in cylindrical polar coordinates, the variables are R, you can most often see S is written in Griffith, pi, and Z. So in cylindrical polar coordinates, what does happen? You just take a cylinder. अब इसके तीन variables क्या क्या हो सकते हैं? Possible three variables to express. So for example, any point lying would be given by some R, some phi will be there, and some height will be there. So any point will be given by R, comma, phi, comma, Z. Okay. Now I'm just writing, and I will explain you all these things as I go in electrostatic. I'm writing that charge distribution will be given by Q, Dirac R, Dirac R, Dirac Z, and Dirac of you can simply say, if I just divide it by 2 pi and r. So basically I'm integrating like phi, because basically your charge is centered at a point, so it does not have a distribution along phi. So it's independent of this phi. I'm just claiming that this would be my charge density. In cylindrical polar coordinates. Let's see, is that true or not? So if I have to cross verify it, all those things I'll make you, I'll write all these things up when I'll be doing electrostatics. But for now, just understand that what I'm doing is I'm just trying to relate something. So for example, if I'm saying that my charge distribution can be written as Q times Dirac R, Dirac Z upon 2 pi r, let us see if I'm right or not. So if I have to find the charge density d tau integral, I should get Q. Is that clear? Because अगर आप charge density को integrate करोगे with respect to your volume, you should get charge, isn't it? You should get charge, and here it is the point charge. So basically, I'm writing the charge density for point charge, so I should get back this point charge. Let us see, am I in a position to get back my point charge or not? So Dirac Z divided by 2 pi times r. Now you have this, instead of d tau, you can write r, you can write dr, you can write d phi, and then you can write dz. Is that clear? Now r gets cancelled with r. D phi, while I integrate in the entire coordinate system, it will give me 2 pi. So here, this will be like Q Dirac R, and then you have Dirac Z dz, and then you have integral d phi divided by 2 pi. So integral d phi would cancel, and this will be equals to 1, and this will again be equals to 1. So answer kya hai? Qi. So in order to get back this Q, I have to scale it. I mean, I have to divide it by some factor. This particular factor is 2 pi r. This is 2 pi r. If I hadn't divided by it by 2 pi r, I would have got a wrong result because then answer would have come as 2 pi into q. So this will create a problem. This will indeed create a problem. So therefore, there will be a need to divide certain things in exam, or otherwise you can just cross verify it by integrating it all back. Is that clear to you? ये चीज समझ में आई कि ऊपर चली गई. We'll write all these kind of expressions as we go along in electrostatics, but overall, just wanted to give you an insight. So that is why I wrote yesterday a formula. If you clearly remember, I wrote a formula. Let's say if I'm finding my let's say this is my r dash, है ना? And let's say this is r. And if I have to write Dirac of r vector minus r dash vector, so basically r vector is a variable, r dash is a point. Okay, so for example, जैसे यहाँ पे नहीं होता था x minus x naught, Dirac of x minus x naught, तो यहाँ पे क्या था? Dirac is situated at x equal to x naught. Similarly, if I write Dirac r vector minus r dash vector, my Dirac is situated at r dash vector. So r dash vector in three dimension, and most possibly in your polar coordinates, spherical polar coordinates can be given as theta dash and this. Are you getting my point? In three-dimensional spherical polar coordinate system, you have r, theta, and phi. Is that clear? So in order to write Dirac cube r vector minus r dash vector, I have to do what? I have to divide it by 1 upon r square sine theta. I have to divide it by 1 upon r square sine theta. And then I have to write Dirac of r minus r dash. Then you have to write Dirac of theta minus theta dash. And I have to write Dirac of z minus z dash. Yes, sir, not z minus z dash, my mistake. Phi minus phi dash. Is that clear to you? Because if I don't do so, then while I'll be integrating this Dirac cube r vector minus r dash vector with d tau, because d tau would then have this term r square sine theta, d theta, d phi, and then dr. Okay, so this term will be there. And if this term remains there, then there will be a problem. So I have to divide it by 1 upon r square sine theta. Is that clear to you? Okay, so therefore in three-dimensional representations, you have to divide it by the scale factors. Basically, those scale factors are something that you know from your orthogonal conveniently coordinate system. So you know that for your three-dimensional spherical polar coordinates, your d tau is given by h1, h2, h3. If you remember dq1, dq2, dq3, and your q1 is r, q2 is I think theta, q3 is I think phi. Is that clear? And h1, h2, h3, this will be 1, this will be r, and this will be r sine theta. So this is r square sine theta, d theta, d phi, and dr. Is that clear to you? So you have to divide it. I mean, you have to divide 1 upon r square sine theta. Otherwise, you will not get back the volume as volume integral as 1. So this is why we do it. Is that clear to you? So this is all the, I'm just recapitulating, I'm just revising what we have done yesterday. Is that clear to you? Am I audible? Is that clear to you? भरत को समझ में आ रहा है? मोनिका को समझ में आ रहा है? कल्पना को समझ में आ रहा है? ये नॉन ट्रिवियल पता नहीं कौन है, नॉन ट्रिवियल को समझ में आ रहा है?
यस सर।
अच्छा तू हो गया नॉन ट्रिवियल यार, तू नाम ही चेंज कर लिया.
सर
ठीक
हमने
है.
इसमें फाइव वाला एलिमेंट क्यों नहीं लिया? आर और थीटा क्यों ले रहे हैं जिससे डिवाइड कर रहे हैं?
हाँ जी सॉरी.
हमने 1/r² साइन थीटा से डिवाइड किया ना.
हाँ,
हम इसमें फाइव वाला एलिमेंट क्यों नहीं कंसिडर कर रहे हैं?
फाइव वाला एलिमेंट क्यों नहीं कंसिडर कर रहे? अगर तुम यहाँ फाइव डैश नहीं लिखते, लेट्स से यहाँ फाइव डैश नहीं लिखते, then possibly 2 pi आ जाता, because then there would be thing. But यहाँ अगर तुम इसको देखो, इसको क्रॉस वेरीफाई कर. Always when you are in a dilemma, just cross verify it. See, if I do this, so if I write r square sine theta d theta, and you have no such term like dependent on d phi, like phi here. So if you integrate Dirac of phi minus phi dash now, so integral of Dirac of phi minus phi dash over entire range of phi would give you 1. Would give you 1.
ओके सर.
So if I had some phi dependent term here now, so I would have divided it. So
ओके सर.
for like in physical instances, you will find that something like here I have divided by 2 pi. Here I have divided by 2 pi. So you'll find all these physical instances as and when we'll write it now. So just as हम आगे बढ़ेंगे, you will be able to understand because I will start electrostatic probably from tomorrow itself. Like जो topic अभी होते जा रहे हैं, I'll start electrostatics from there onwards. Let's say we have now come to a position that where we can write some charge distributions. So at least we can study charge distributions. Like for example, continuous charge distribution, discrete charge distribution. So ये सब चीजें on the very physical level I'll teach you tomorrow that why I did so and why I didn't do it in this fashion. Because you see यहाँ पर क्या होगा, had I written delta phi here, then कोई दिक्कत नहीं थी. मतलब अगर if I don't write 2 pi here, then I should write delta phi here because then delta phi integral would be 1. But if I write 2 pi here, then I cannot write like delta phi here because if I write delta phi, then integral delta phi d phi would be 1. So are you getting my point? So यहाँ पर
Yes, sir.
क्योंकि जब इंटीग्रेट करोगे तो d phi you'll get 2 pi, so 2 pi gets cancelled with 2 pi. So all these kind of manipulations on all these kind of things may come in examples. For example, for instance, I'll give you an example. The same thing can be written as this. If I'm not wrong, just cross verify it. If I write this kind of expression, is that right? So if I write Dirac of r vector minus r dash vector, Dirac of if I remember, this should be cos theta minus cos theta dash, and then Dirac of, I think this should be phi minus phi dash. Just try to find that, is that the right representation? So I'm writing is the above expression, yeah, above equality right? Is the above equality right? Okay, not sine theta in that particular case. I think it should be only but just try your hand at this. Just try your hand at this. Is that right? 1 upon r square, Dirac of r minus r dash, and then Dirac of cos theta minus cos theta dash, and Dirac of phi minus theta. Just try your hand at this. Because as if I remember, just trying to see the question if it has come in the examination itself. Just give me a minute. No? Just give me a minute. You meanwhile just try to figure out. Just I'm giving you a minute. I was just figuring out the question. I'm not getting it right now, but overall, just try to understand. Let's say this is the like this is a problem that I've given to you. If I was just figuring out, it was given in the examination itself. So if I'm not wrong, so instead of theta minus theta dash, if I replace it by cos theta minus cos theta dash, does this expression or does this amount to saying that this and this are equal? Okay, so let us first see if what, because all these things are similar. All these things are similar. We have only change in this, like cos theta minus cos theta dash. So So what I will write here Dirac of cos theta minus cos theta dash. Okay, so first you have to understand, yesterday also I told you, and also remember that theta lies between pi and 0 in your three-dimensional coordinates, three-dimensional spherical polar coordinate system. Is that clear? So how to write this particular expression? So how to write this particular expression? So let us do it. So for example, if I have this, I have to first see that my cos theta is equals to cos theta dash. At what point does that happen? So when does this particular thing happen? So when does this particular thing happens? It happens only if theta is equal to theta dash. Is that clear? Or otherwise you can write theta should be equals to 2n pi plus theta dash, because your cos theta is a periodic function with period 2 pi. But overall understand, since my theta lies between 0 and pi, so this solution will only be possible if n is equal to 0, because as n is equal to 1, then it will be 2 pi plus theta dash, and that would obviously not come in this particular this particular range. Is that clear to you? So here I can write my cos theta would be equals to cos theta dash, and that implies my Dirac delta function, this argument will be 0 only if theta is equal to theta dash. Is that clear to you?
Yes, sir.
Is that clear? So for example, yesterday we did that if I have some Dirac of g of x, then it is equals to what? It is equals to Dirac of, I think it was x minus xi divided by modulus of g dash xi. I think, and this was it. Is that clear to you?
Yes.
Okay. So what I would say that if I write instead of this, if I just write it in this fashion, Dirac of theta minus theta dash, okay, not Dirac of theta minus theta dash, and then I can write, sorry, what I can do is, like for example, I'll tell you this, all of these things here. So for example, if I have this kind of thing, so if I have Dirac of cos theta, so if I had Dirac of cos theta, then I would have written it as summation Dirac of theta minus, I think, theta divided by cos theta का derivative is sin theta, and this would be theta minus, I think, theta i's. Theta i's are all those points where your cos theta is 0. Is that clear to you? It should be the case, isn't it? Now similarly, if I have this cos theta minus cos theta dash, like cos theta minus cos theta dash, then it will be I think summation Dirac of theta minus theta dash, Dirac of theta minus theta dash divided by sin theta modulus. Is that clear?
So sin theta dash.
Sin theta dash, sorry. Sin theta dash. Sin theta dash. Is that clear? So, is that clear to you? And here I don't have
Yes.
to write this. I don't have to write this summation, because I have only like if you just plot this thing, so you have only one solution. You don't have like infinitely many solutions. In general, you had infinitely many solutions, but overall, you have only one solution, that theta has to be equals to theta dash. Had it been a period, had it been if theta was, if I had not created this bound, the general solution would have been theta is equal to 2n pi plus theta dash. But now you don't have this theta is equal to 2n pi plus theta dash. Now theta has to be equal to theta dash. So overall, this particular expression would become Dirac of theta minus theta dash divided by modulus of sin theta dash if you write, or even if you write modulus of sin theta, it will be one and the same thing, because theta is equal to theta dash. So overall, instead of writing this entire thing, you can write this particular expression, which I'm writing here. You can write this particular expression as Dirac of theta minus theta dash divided by sin theta ka modulus. And whether you take modulus or whether you don't take modulus, much of things won't change, because sin theta is positive in the first and the second quadrant. So overall, mod likho, mat likho, one and the same thing. So sin theta will come here, 1 upon r square sin theta, Dirac of r minus r dash, Dirac of theta minus theta dash, and Dirac of phi minus phi dash. This is what we have written here. Is that clear to you? So if I remember, actually, I was finding that only. It was asked in TFR. If I'm not wrong, it was asked in TFR. That is why I'm explaining you. So are you getting my point? or should I repeat it all over again? देखो मेरी बात समझो, यहाँ पे देखो फंक्शन क्या था, डिराक जीएक्स, याद करो डिराक जीएक्स। अगर डिराक डेल्टा के अंदर इफ द आर्ग्यूमेंट इज रिप्लेस्ड बाय अ फंक्शन, व्हाट डू, यू जस्ट फाइंड द values your function is zero. So let's say it is zero at points xi's. So मान लेते हैं xi's are those point, मतलब बहुत सारे xi's हो सकते हैं, I don't know how many are there. Then this particular thing amounts to writing this. Is that clear to you? Point number one. Now instead of gx, now you have some function of theta, and that is cos theta minus cos theta dash. So you have to see where this particular function is zero. This particular function will be zero if theta is equal to theta dash. Is that clear? And further, also remember that theta must lie between 0 and pi in the spherical polar coordinate system. This is something that you remember from your elementary classes. So overall, not elementary, but otherwise in BSc classes, you know all these things. Okay. Now, overall, understand my point that now, instead of writing Dirac of cos theta minus cos theta test, this will be replaced by this variable x. So what is this variable? This variable is theta. And what are those roots which I'm referring to? The roots are theta dash. So cos theta equal to theta dash. So this root is theta dash. Now I cannot write a sum because now you have only a single root. Had it not been the case, you would have written theta should be equals to 2n pi plus theta dash. But now 2n pi does not comes in the scenario because n equal to, even if you place n equal to 1, then this will be 2 pi something. And 2 pi something does not come in this particular range. So overall, this will remain theta minus theta dash, and you will divide it by sine theta dash modulus. And you write whether sine theta dash or whether you write sine theta, they are one and the same thing because theta is equal to theta dash. So overall, this Dirac of cos theta minus cos theta dash, sorry, cos theta dash is equals to Dirac of theta minus theta dash divided by modulus of sine theta. And whether you write modulus of sine theta or you don't write modulus of sine theta, it is fine because sine theta is positive for all first and second quadrant, for all values of theta in the first and the second quadrant. So modulus value means the same thing. You can write same thing. So eventually you will get this kind of thing. So 1 upon r square, this will give you del theta minus theta dash divided by sine theta. So you have the sine theta coming from here. So 1 upon the r square sine theta, Dirac of r minus r dash, Dirac of theta minus theta dash, Dirac of phi minus phi dash. So equally as well, like you have written this in this fashion or you write in this fashion, they are one and the same thing. So all of these things I have taught you yesterday itself. Okay, I don't think much of it was today's lecture. Much of it is revision only because I hope to deliver you the best because this is the last class that I'm taking. Then mostly I will take the class on physics side, not on the math side. So whatever mathematics is required, I'll finish it off today itself. So this is what my target is. Is that clear to you?
हाँ भैया.
Okay. Now let us move ahead to another thing, and jahan se what we left where we left things from. So we left things at this particular point. That is my if I was writing my Dirac nx as sine nx upon pi x. So if I do this kind of thing, so I told you on the very first day, probably that lecture was not recorded, so I'm just keeping it all over again. I'm just recording it all over again. So this was one of the representations whose limiting case may behave as a Dirac delta function. So instead of writing this, I wrote like e की power iota nx minus e की power minus iota nx upon pi x. Is that clear to you? So this is Dirac nx. Okay, and overall, understand my point that if this particular thing can be written in certain, we can manipulate this particular thing with certain things. So, for example, if I have to write Dirac x, so my Dirac x is nothing but limiting behavior of Dirac x. And instead of all these things, if I just write, I think there should be 2 iota also here. So I should write 2 1 upon 2 pi. Forget about this constant of integral. I'm not that worried about it. हाँ जी बोलो.
भैया स्क्रीन जूम आउट हो गया है, दिख नहीं रहा है.
Zoom out हो गया. अभी zoom in है. क्या है मतलब? I don't know.
मतलब वो बड़ा हो गया स्क्रीन तो दिख नहीं रहा है. 100 स्क्रीन की साइज बड़ी हो गई है.
ऐसा एक
हाँ
मिनट वापस करूं क्या?
हाँ डिफॉल्ट पे डालना पड़ेगा.
ऐसा इज दैट विजिबल?
नहीं स्टिल नॉट.
ओके, एक काम करते हैं. ये विजिबल अभी नहीं है?
अब विजिबल है.
ओके, सो देखो नाउ instead of writing from minus n to plus n, I'll write e की power iota and I will write kx and I will write dk. So now this particular integral would give me iota x in the division. So I have iota x, I have 2 pi. So 1 upon 2 pi iota x, and I have written in this way. Is that clear to you? And if you remember this particular thing, 1 upon 2 pi, integral from minus infinite to infinite, dk e की power iota kx, what does this represent? So if you go in the literature and if you find what is Fourier transform, so what are Fourier transforms? So Fourier transform would be given like you can see that like I'll write it here. So if I write Fourier transform of function fx, then I will write the Fourier transform of function fx is given by integration from minus infinite to infinite fx e की power iota, probably plus minus. So you'll find in certain books this is given because see, I don't understand this thing that what is what I mean. There are places where you'll find that this is given as Fourier transform plus one. So like they're inverses of each other. So I will write only plus for right now. So this is iota kx. एक काम करते हैं ना. So I'll write this in this fashion. 2 minutes रुको. Because there are confusions regarding this Fourier transforms also. So एक काम करते हैं. I'll write a certain notation for this. So if you remember from your Fourier transform thing, so this particular thing is your kernel of Fourier transform. We'll come to all these things later. This is your kernel of Fourier transform. So basically what is happening? Things you can see that here it is in unity here. Like if I just replace it by unity, I can write this unity also. So how do we write Fourier transform? The Fourier transform are written as, if I write my Fourier transform function, I can write in this fashion, minus infinity to infinity. Some of the people write 1 upon root over 2 pi. In some literature, you'll find 1 upon 2 pi. Forget about this. Forget about this. Overall, just understand what I'm trying to write. So if this is your Fourier transform, this is your called as inverse Fourier transform. Okay. Okay, so this is called as inverse Fourier transform. Or if you call this Fourier transform, so I'll say both are inverses to each other. But overall, I will call both of them as, in general, Fourier transforms. Okay, so this is your Fourier transform, and this is your inverse Fourier transform. But overall, it is a Fourier transform. Okay, are you understanding my point? So if I just find, if I can write that the Fourier transform of Dirac Delta function is 1, or Fourier transform of 1 is Dirac Delta function. Is that clear to you? So I will write here Fourier transform of Dirac Delta function is just unity. Or you can say that, I mean, if you take a Fourier transform of 1, you will get this Dirac Delta function. Or if you just take an inverse Fourier transform, then so because basically what does this is like iota kx, this is here positive. So in order to write the Fourier transform of Dirac Delta function, you have to multiply with e की power minus iota kx. So I would write Fourier transform Dirac Delta function is just unity. Is that clear to you? Is that clear to you?
Yes, sir.
Okay. And further, if I just write it in this fashion, so you have come to a point where you can write you can say a Dirac delta function in some integral form. So this is at times referred to as the integral representation of Fourier transforms. At times you'll find this has to be written as integral representation of Fourier integral representation of Dirac delta function. Is that clear to you? So at times you should not get confused like with this 1 upon root 2 pi. That is why I was not writing it. Even if you want to write, you can write. Much of it, I mean, I'm not concentrating here, I'm just concentrating here. So you understand, if I'm writing fx into e की power minus iota kx, then I'm writing the Fourier transform of fx. And if I have to write, again, this is inverse Fourier transform, or you can say the Fourier transform of this particular function. So basically, if I go by the same way, I can say that the Fourier transform Dirac delta function is just unity. So I'll continue it in the next session.